Hey guys, welcome back to the lecture on the TensorFlow by Uplatz. So in the previous lecture, we have seen what are the different types of artificial neural network. So let's continue with what are the components of an artificial neural network. So in this lecture, we will see what are the main components of an artificial neural network. So you can see the first one is the neurons. So neurons are similar to the biological neurons. Neurons are nothing but the activation function. Artificial neurons or activation function has a switch on characteristic when it performs the classification task. We can say when the input is higher than a specific value, the output should change state, that is 0 to 1, -1 to +1, etc. The sigmoid function is commonly used activation function in the artificial neural network. So you must understand that the neurons are similar to the biological neurons. They're also called as activation functions. So they have a switch on mode when it performs the classification task. So when we give a particular input, we expect that the output should change the state, that is 0 to 1 or -1 to +1, etc. The sigmoid function is commonly used activation function in the artificial neural network. So it is given by f of z equals 1 divided by 1 plus exponential of -z. Okay, so this is the function given in the artificial neural network. Then we have nodes. The biological neuron is connected in hierarchical networks, with the output of some neurons being the input to others. These networks are represented as a connected layer of nodes. Each node takes multiple weighted inputs and applies to the neuron to the summation of these inputs and generates an output. So the node is a biological neuron that is connected in a hierarchical networks, with the output of some neurons being the input to others. These networks are represented as a connected layer of nodes. Each node takes multiple weighted inputs and applies to the neuron to the summation of these inputs and generates an output. So it's quite common in the neural networks that it consists of many nodes. Then the next component is bias. In the neural network, we predict the output based on the given input. We create a model, that is mx plus c, which helps us to predict the output. When we train the model, it finds the appropriate value of the constants m and c by itself. The constant c is the bias. Bias helps a model in such a manner that it can fit the best for any given data. We can say that the bias gives freedom to perform the best. So this bias is the constant in mx plus c. The bias helps a model in such a way that it can best fit for the given data. We can say bias gives the freedom to perform the best. So then the algorithm. The algorithms are required in the neural network. The biological neurons have self-understanding and working capability, but how an artificial neuron will work in the same way. For this, it is necessary to train an artificial neural network. For this purpose, there are some algorithms used. Each algorithm has a different way of working. I'm showing you some very important algorithms which are used in training of the ANN. The first one is gradient descent. The second one is the Newton's method. The third one is the conjugate gradient. The fourth one is the Newton's. The next is the Levenberg-Marquardt. Okay, so these are the popular algorithms for the ANN. The gradient descent algorithm is also known as the steepest descent algorithm. It is the most straightforward algorithm which requires information from the gradient vector. Gradient descent algorithm is a first order method. So it's also known as the steepest descent algorithm. It is the most straightforward algorithm which requires information from the gradient vector. Gradient descent algorithm is a first order method. For simplicity, we denote fw of I equals f of I. The method starts from w of 0 and moves from w of I to w of I plus 1 in the training direction d of I equals minus g of I until a stopping criterion is satisfied. So the gradient descent method iterates in the following way. W of I plus 1 equals W of I minus G of I multiplied by N of I. So this is the gradient descent method, which is also popularly used in machine learning. Then is the Newton's method. Newton's method is a second order algorithm which makes use of the Hessian matrix. Its main task is to find better training directions by using the second derivatives of the loss function. Newton's method iterates as follows. So W of I plus 1 equals W of I minus H of I minus 1 multiplied by G of I for I equals 0, 1 to so on. Here H of I minus 1 multiplied by G of I is known as the Newton's step. The change for parameters may move forward or towards a maximum rather than a minimum. Below is the diagram of the training of a neural network with Newton's method. The improvement of the parameter is made by obtaining the training direction and a suitable training rate. So this was about the Newton's method. It's a second order algorithm. Its main task is to find better training directions by using the second derivatives of the loss functions. The third one is the conjugate gradient, which works in between gradient descent and Newton's method. Conjugate gradient avoids the information associated with evaluation, inversion of the Hessian matrix, and storage as required by Newton's method. In the conjugate gradient algorithm, searching is done in a conjugate direction, which gives faster convergence rather than gradient descent direction. The training is done in a conjugate direction concerning the Hessian matrix. The improvement of the parameter is made by computing the conjugate training direction and then suitable training rate in that direction. So you can see the diagram. We have to evaluate the loss index. Then as long as the stopping criteria is false, you need to improve the neural network parameter. You need to find conjugate gradient, training direction, and training rate. So we need to stop when the stopping criteria becomes true. So in this algorithm, the searching is done in a conjugate direction, which gives faster convergence rather than the gradient descent direction. The training is done in a conjugate direction concerning the Hessian matrix. The improvement of the parameter is made by computing the conjugate training direction and then the suitable training rate in that direction. The next one is the Cauchy-Newton method. applications of the Newton's method are costlier in terms of computation. To evaluate the Hessian matrix, it requires many operations to do. For resolving this drawback, Cauchy-Newton method developed. It is also known as variable matrix method. At each iteration of an algorithm, it builds up an approximation to the inverse Hessian rather than calculating the Hessian directly. Information on the first derivative of the loss function is used to compute approximation. So this is the Cauchy-Newton method. So application of the Newton's method are costly in terms of computation. To evaluate the Hessian matrix, it requires many operations to do. For resolving this, Cauchy-Newton method developed. It is also known as variable metric method. So the improvement of the parameter is made by obtaining the Cauchy-Newton direction in the training and then finds a satisfactory training rate. So this was the Cauchy-Newton method. Then finally, the advantages and disadvantages of neural network, the artificial neural network. The advantages are it stores the information on the entire network rather than the database. After the training of ANN, the data may give the result even with incomplete information. If one or more cell is corrupt of ANN, it does not prevent ANN to generate the output. ANN has distributed memory that helps to generate the desired output. ANN can make a machine learnable. ANN has a parallel processing capability, which means it can perform more than one task at the same time. So these are the advantages of ANN. The first one, it stores the information on the network rather than on the database. Then after the training of ANN, the data may give the result even with the incomplete information. Then if one or more cells of the ANN becomes corrupt, it still generates the output. ANN has distributed memory that helps to generate the desired output. ANN can make a machine learnable. ANN has a parallel processing capability, which means it can perform more than one task at the same time. Then, what are the disadvantages of ANN? It requires a processor with parallel processing power according to their structure. Unexplained behavior of the network is the main problem of the ANN. ANN does not give a clue when it produces a probing solution. For the determination of the structure of ANN, no specific rules are provided. There is no information about the duration of the network. Then the final one, it's too typical to show the problem to the network. So these are the drawbacks of ANN, which are not that matter. You need to remember the advantages of ANN. Okay, so this covers the components of artificial neural network. So any doubts, you can mail us. All right, thank you.